Hello students, today we will be going over 10.2, solving systems of equation by substitution. Our objective, I can solve a system of equations by substitution. And here we have a system of equations right here. We have this equation, y equals 5x plus 7, and this equation, negative 2x plus 3y equals negative 5. Now, if something is already solved, like this y equals doesn't have an x with it or a constant or a number with it, that means it's isolated. This one is not isolated because it has x and y on the same side. So whichever one is by itself, we want to use this part, the 5x plus 7, and substitute it in for the y down here. Okay, so then you see this is written exactly like equation 2, except for they replace the y with the 5x plus 7. And then they do the distributive property and they do the steps to solve for x and y. So our solution to both of these equations is negative 2 comma negative 3. Okay, so here are our steps for substitution right there. And we are going to go ahead and do one of the problems or some problems and follow those steps. So the first one we're going to start out on is doing number 1. At the bottom of page 192. So we say y, again, this is page 192. Y equals 6. So we're going to take this 6, because it's y equals, and we're going to put it in for that y right there. So we say that 6 equals negative 7x minus 22. Then we're going to add 22, add 22. This is 28 equals negative 7x. This goes away. Divide by what's in front of x, negative 7. So x equals negative 4. Now normally we would have to go back and plug the negative 4 into one of the equations, but since this is already solved for y, we know that y equals 6. So our solution is going to be our x value, negative 4, and our y value, 6. And we're done. Now let's go on to the next problem. X equals 1, and negative x minus 3y is negative 19. So we say which one is isolated? Oh, actually you're supposed to put which variable is isolated, we want to put y. Over here, which variable is isolated? You want to say x, because see how this x is by itself? Now we're going to substitute this 1 in for that x value right there. So we say negative 1 minus 3y equals negative 19. Add 1 here. Negative 3y equals negative 18. Divide by negative 3, y equals 6. Okay. Now again, in this situation, we already know what the x value is. We're going to put x equals 1. Then we put them in ordered pair form, and that is going to be 1. You always want to put your x first. 6. That's where some people make mistakes. They think just because they solved it, that's going to be the x value. So pay attention to which one's x value and which one's y value. Okay. Next, we are going to be going on to page 193. I'm going to jump to a couple of harder problems. Right here, we say which one is solved for y. This says 7x minus 6y. So those are on the same side, so it's not by itself. This y is isolated or by itself. So we're going to actually take this whole thing and we're going to substitute it in for that specific y. So we say 7x minus 6 parentheses 7x minus 9 equals negative 16. Okay. Then we're going to use our distributive property, and there's yellow steps on your desk that go through how to solve for the variable. So 7x minus 42x plus 54 equals negative 16. Then we combine 7x and negative 42x, and you get negative 35x plus 54 equals negative 16. Technically, I should draw a line down right there. Minus 54, minus 54, negative 35x equals negative 70. Divide by negative 35. And you can use your handy dandy calculator. And x equals 2. Now, we don't know what y is yet, so we need to plug it back in. So we're going to plug it back in to the easier equation. Since this is solved for y, that's a little bit easier. So I'm going to put y equals 7x. So the x, I'm going to substitute in the 2 minus 9. So y equals 14 minus 9. So y equals 5. So your answer is going to be 2, 5. Okay. All right. Next, we're going to go ahead and do number 10. Say, what if they're both isolated, Miss Rupert, and they both have x's? Then what do I do? Well, we just pick one, and I'm going to pick this one and substitute it into the other one down here. So I'm going to get 5y minus 3 equals y plus 5. Now, when I write this equation, there should be only one variable, either all y's or all x. Oh, by the way, on this one, when it asks which variable is isolated, this is going to be the y. For this one, which is isolated, you say x. So we know that we won't have an x here, like we won't have a y here. So whichever variable is isolated, that's the one you won't be solving for. Okay? So now we have to get the y's on the same side. 4y minus 3 equals 5. Add 3. 4y equals 8. Now we're going to go ahead and plug it back in. We could do either one. To me, the easier one is 2 plus 5. So again, I bring that down here, and x equals 7. So again, we put it in ordered pair form. X has to go first. So we can put 7, 2. All right, students, you can do the rest of this. You rock.